Hi, this is Amit Kirti here. In this video, I would like to talk about operators in a C or C++ program. Now, C or C++ provides a number of operators. Some of them are called arithmetic operators. For example, adding using plus or subtraction using minus, multiplication, division, the percentage. Then you have some unary operators like plus a or minus of a. Then you have unary increment operators like plus plus a plus plus, minus minus a, and a minus minus. You also have relational operators like a equivalent to b, a not equal to b, a less than b, a greater than b, a less than or equal to b, and a greater than or equal to b. There are certain logical operators which are also supported, for example, bang operator, and operator, or operator. So it could be A and B, A or B. So it will evaluate to either true or false. So if both are true, it will be A and B will be true. If either of them is true, A or B will be true. There are certain bitwise operators that are also supported in C or C++ programming. So some of them are A left shift B. So if you want to left shift A by certain number of bits, you use this. This is A right shift of B. Then this is a NOT operator, and this is an AND operator. So A and B. So we will check whether both bits are 1. This is A or B, so ORing 2 bits. And this is A XOR B. There are some more compound assignment operators. For example, plus equal to means A is equal to, if I write A plus equal to B, it actually means A is equal to A plus B. Then we have minus equal to, so A minus equal to B means A is equal to A minus B. Similarly, star equal to means A star equal to B would be evaluated as A is equal to A star B. Similarly, slash equal to or percentage equal to, and equal to, or equal to, or XOR equal to. So there are a couple of more which I am skipping here. Then we have member and pointer operators. So star of A is to dereference a pointer. Ampersand of A is to obtain the address of the variable A. Then the arrow mark is to go to a particular variable using a pointer. So A arrow mark B would actually mean that A is a pointer to a structure, and B happens to be a variable inside the structure. So A of B means we are trying to access the B variable inside a structure pointed to by A. And the dot operator is used again in the same context, but in this case we would not have a pointer. So A dot B means A is a structure and B is a variable inside the structure. So when I do A dot B, I'm trying to access the variable B inside the structure A. Then we have various other operators like the opening and closing bracket, which we use for arrays. This is a ternary operator. So it is like an if else kind of an operator which does it in one shot. Then we have a comma operator. For example, we could write int x comma y comma z. So in variable declaration and definition we can use comma. Then we have the size of operator to determine the size of a variable. And then finally we have this opening and closing bracket. This again would be used for, say, typecasting and various other usages, like to differentiate two operators of the same priority levels, which we will see in future. So these are some of the many operators Probably we covered about 90 to 95% of the operators. So these are the operators that are used generally in a program that we write. So how are these operators generally used in a C program? We will see in the next few examples and try to evaluate how they operate in conjunction with each other. So let's take this first example. So in this, I have int I is equal to 1 plus 2 star 3. So I know the answer is 7. So I would actually do star first, then plus. So why do I actually do that? Why do I evaluate 2 star 3 and then add 1? That's one of my questions. Then here I am doing 1 star 2 star 3, or I could have done 1 star 2 slash 3. So in what order will this be evaluated? And why is it evaluated the way it is evaluated? So these are some of the questions that I have. The second program is I have an int variable I have assigned it to 2. Then I have j is equal to I left shift operator 1 plus 4. So there are two operators here. One is the left shift operator and one is plus. So in what order would this be evaluated? Would I do 2 left shift of 1 and the output is added with 4? Or I would do 1 plus 4 first and then whatever I get, that is 5. Then 2 is left shift by 5. So I have two options. So in the first option, I will get an answer as 8. In the second option, I get an answer as 64. So the answer for this is it 8 or is it 64? The third example here is a complicated expression inside an if. So I have 4 star 6 less than 9 star 8 and 4 by 2 less than 2 plus 1, or 2 left shift of 3 greater than 6. Is this a valid expression? And if it is a valid expression, how is it evaluated? So these are some of my queries. The final example in this context is I have two statements here. The first one is int I is equal to j is equal to k is equal to l equal to m equal to 7. So is this a valid statement? And if it is a valid statement, what exactly does it mean and how is it evaluated? The second line that I have is, say p is equal to 5, q is equal to 2 and r equal to 10. So I write r plus equal to p star equal to q left operator equal to 3. How is this evaluated? Is it a valid expression? So these are some of my queries. I have one more example here. I set I is equal to 1, j is equal to 0. Then I do j is equal to I plus I plus I, or I could have done it as I plus I plus plus. So in this case, when I print I and j, what would be the values? A similar example is given below. Instead of j is equal to I plus I did I is equal to I plus I. So is this a valid statement and what would be the value? Now I actually have a statement like final is equal to 1 plus 2 star 3. In this case, I know that 2 star 3 gets evaluated first, then I add 1. So this is fairly well known. So a multiplication operator gets evaluated first and then the addition operator. So taking the same context further, if I have a function f, another function g, and another function h, and in the main, if I do something like this, f plus g star h, then in what order are these functions called? Do I call function g and then I call h, I multiply the values, and then I call function f, or function f is called, then g is called, then h is called. So in what order are the functions called? So this is another query that I have with respect to this program. So in order to understand and evaluate all these expressions, we have to know what is the order of these operators and in what order are they evaluated. So here are some of the operators and they are listed in the order of evaluation or order of priority, and we also have some associativity associated with these operators. So let's see what this table actually means. What it means is, as we go down the order, the priority of the operators also keeps decreasing, which effectively means these brackets dot, arrow, I plus plus and plus, I minus minus have the highest priority. Then star, these are all unary operators, star, ampersand, plus minus, bang, and plus plus I and minus minus I, and not, size of and typecast. So these form the second level of operator priority. At the third level, I have star, slash, and percentage. At the fourth level, I have the binary operator plus and minus. Then I have left shift and right shift. Then I have these comparison operators. Then I have equivalent to, not equal to. Then I have these bitwise operators. Then I have these logical operators. Then the ternary operator. Then the assignment operators followed by a comma. So this is the order of evaluation. And then if in an expression I have operators from the same level, for example A star, B star, C, then they are evaluated from left to right, and some of them are evaluated right to left. So if we have operators from these different levels, they will be first evaluated based on this order. And if I have multiple operators from the same level, then I will actually evaluate that expression from left to right. So let's try to look at our various examples and see how this fits into the picture. So here I have listed all the operators on the right hand side, and I will try to pick each of the example. So in this case, the first line says 1 plus 2 star 3. So I see that star operator is much ahead of plus operator. So star will be evaluated first, then plus, because plus comes below star. So 2 star 3 is evaluated first, then 1 is added to it. In this case, that is 1 star 2 star 3 or 1 star 2 slash 3. Star, there are two stars here and there is a star and a slash here. So star and slash are on the same level. So once you have multiple operators from the same level, you will evaluate it left to right. So 1 star 2 gets evaluated first and then 3. So we see here that when we have 1 plus 2 star 3, since star is above plus, star gets executed first, and in this case, if they are both operators are at the same level, we will go from left to right. Now let's look at the other example. So 2 left shift of 1 plus 4. So what we see here is that plus operator has more priority compared to a left shift operator. So what exactly happens is that 1 plus 4 is evaluated first, which gives me 5, and then I do a left shift operator. So 2 is left shift by 5 positions to get 64. So left shift is not done first, it's the plus operator that gets executed first, which can be concluded from this table. Now in this complex evaluation, I see that between these two operators, star and less than, star is first, so I will evaluate 4 star 6 first. Then again between operator less than and star, star is first, so 9 star 8 is evaluated. Then we do a comparison. So this gets evaluated first, this gets evaluated second, then we do a less than, which can be again confirmed from this table. Star is higher priority than less than. So this and this get evaluated first, and then we do A less than B to get an answer for this. So we store this answer here. Then we do 4 by 2, and let's say we call it D, and then we do 2 plus 1, let's call it E. Then these two values are compared, that is D less than E. So let me call it F. So first I evaluated this part, then I evaluated this part. Now I do an AND of these two, that is C and F. So in this case, 6 into 4, 24 is less than 9 into 8, 72. So this is true. 4 by 2, which is 2, is less than 2 plus 1, 3. So this is also true. So when I do an AND of true and true, I get an answer to true. So this whole expression would get evaluated as true. So the second part never gets evaluated. So we skip the second part because the OR operator works in such a way that if one of the operator is true, the second operator does not get evaluated. So this whole thing gets evaluated first. If this was false, then the order of evaluation for this would have been 3 is less than 6 would have been evaluated first. Oh no, sorry. The left shift operator has higher priority than the comparison operator. So 2 would get left shift 3 times. So the output would actually be 16. 16 is greater than 6 would be true. So if this was false, this would have been true. So OR of this would have been true, and we would have printed this statement. Now let's look at this particular example. So we have I equal to j equal to k equal to l equal to m equal to 7. So this would actually mean that I, j, k, l, m, all of them would be assigned to 7. So the order of evaluation would be right to left for equal to. So m equal to 7 would be evaluated first, and the answer would be stored in L. That answer would be stored in K. That answer would be stored in J. That answer would be stored in I. So you go from right to left in this case. And in this particular evaluation, again, this is a right to left evaluation. So first we will do Q is equal to Q left shift of 3. So Q equal to Q left shift of 3 would be Q is 2. So 2, when we do a left shift of 3, we get 16. Then we do P is equal to P star, the answer 16. That is, P is 5 in this case. So it will be 5 star 16, which is equal to 80. And that 80 is an input parameter to this. So R will be equal to R plus 80. In this case, R is 10. So 10 plus 80 would evaluate to 90. So the answer for this would be 90 when we print the value of R. Next, we will try to learn something called as sequence points. Before sequence points, we will just try to understand what is the sequence points. So a sequence point is a point in time at which the dust has settled and all side effects which have been seen so far are guaranteed to be complete. The sequence point listed in C standard are at the end of evaluation of a full expression, at the end of OR and or ternary operator and a comma operator, or at the end of a function call. So what exactly this means is, at the end of these three things that are listed here, when we reach one of these three, the values associated with this expression would get a proper meaningful value. If we try to access a variable before we hit any of these three conditions, those variables might be in an indeterminate state. So if we try to use those variables, we might get an indeterminate answer. So let's try to see what this exactly means in the context of some of the examples that we have seen. So I have listed down the three sequence points on the right hand side. So for to hit a sequence point, the expression should have been evaluated completely. If not, we should have at least reached OR, AND or a ternary operator. If not, there should have been a function call at that end of the function call, we would have reached a logical sequence point. Now in these two examples, when I do I plus plus, then I do plus 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 I am actually trying at this point, I am trying to access the value of I which is not yet ripe or which has not been evaluated as per the sequence points. So when I try to access I again here, because here I am trying to increment the value of I. For this to be incremented, the value of I should be known at this point. But this operator I plus plus is not complete till the semicolon. So I should not be accessing I again till I reach a semicolon. But here I am accessing I again here. So which effectively means I am trying to access the value of I before reaching the sequence point, because the expression is not complete. I have hit a plus operator, not one of these operators, and there is no function call here. So accessing I at this point leads to an indeterminate value. Same would be the case in this expression, because when I am trying to access I here, this I plus plus would not be complete. So this would actually give me an indeterminate value. So none of the sequence points are hit. So in both these cases, I would get an indeterminate response. Now in this case, this is an interesting example. If you look at the output of this, the output would be F gets called first, then G gets called, then H gets called. But the evaluation is G and H are multiplied first, then F. So function calls are not dependent on operator precedence. Just because there is a plus here and a star here doesn't mean that G has to be called first, H has to be called first, and they have to be multiplied then F. In this case, F would get called first, G would get called next, H would get called next, and F would return 1. So 1 is stored here, G would return 2, so 2 would be stored here, H would return 3, so 3 would be stored here. So the expression is complete, but when evaluation of the expression happens, we multiply the return value of G and H, which is 2 and 3. So 2 into 3 is evaluated, and then we add the value of F. So function calls go in the normal order, but the return values are placed in this expression, and expression is evaluated as per the operator precedence. So would this change if I add a bracket between G and H? So suppose I add, because a bracket has a highest priority, so if I add a bracket between G and H, will G be called first, then H? In fact, no. So it would still evaluate by calling F first, then G first, then H first, but it would multiply the outputs of G and H and then add the output of F. So these were some of the examples for operators and their precedence and the way they are used in C and C++. Thanks for watching the video.